Hello, hi to everyone. So welcome to our next video on previous year question papers from chapter number 1, circuit fundamentals. Okay, according to our schedule, we completed circuit fundamentals theory classes. These are the 4 theory classes: zero and reference level, and charges is ground, Ohm's law, linear and non-linear elements, work and power, and series and parallel circuits. I hope that those are enrolled. I hope that they are completed these videos. So now we are moving to the explanation about how once you learn the concept and theory, just your preparation should be examination oriented, then only will succeed. So once your theory classes are done, I will explain the previous year question papers now. Once you are after explaining the previous papers, you know what is the standard of examination. After that, we are providing the test series for circuit fundamentals and each and every chapter. Then you can practice that particular test series. We'll get some marks. Based on that, you can analyze where you stand, and then you start your preparation in the more focused way, more examination point of view. Okay, right. So now this is a question: power dissipated in 10 ohm resistance will be. This is the first question from 2008 question paper, right? So here they are asking about the power. So P is equal to I square R. You know this formula. You know current. You don't know the current. You can find out the current flowing through this resistor. You know resistance. Yes, this is the 10 ohm resistor. It is mentioned in the problem. So I need to find out the current first. I is equal to V by R. What is the V here? 120 volt, here 65. Both are connected, here plus sign, here plus sign. Both are opposite. According to Coulomb's law, opposite means that subtraction. 120 minus 65, right? Divided by, that is the resultant voltage, divided by resistance. What is the resistance? Equivalent resistance of total entire circuit, then only we'll get the current. So how to find out the equivalent resistance here? Here, series and parallel combination technique. So RT, total resistance. This resistance is different. You want to find out the power, you can use this resistance only 10, because they are asking about power dissipation in 10 ohm resistance. But while you find out in the current, you need to, in between these 2 points, this resistance and this resistance, total entire resistance connected, that current will, while you're calculating the current, you need to consider all resistances, right? This 10 ohm plus this 30 in series. These two are combination is parallel. 20 into 60 by 20 plus 60. Okay. So that will be equivalent to 40 plus 15. That will be 55 ohms. All of you got idea? So substitute here 55. So finally 55 divided by 55. What is the current now? 1 ampere. So once you got the current 1 ampere, so therefore power is equal to I square R. What is the I according to this formula? 1 square R. What is the power dissipation in 10 ohm resistance, right? That is R. That will be equivalent to 10 watts. So look at the options. Here option D is the correct option, 10 watts. Clear? So this is a way you need to find out the solution. It is very simple once you know the basic idea about the circuits, series and parallel combination. Next question number 2. How many connecting terminals does SPDT switch drive? Okay. So first of all, we'll see what is mean by SPDT. SPDT means single pole double through switch. That is SPDT. So I will give some important theoretical background related to the SPDT. So see, it is the most commonly style of switch is SPDT mechanism switch. The SPDT stands for single pole double through. Simply stated, the on common terminal on the switch where the voltage and currents applied, and the voltage and current can be either directed to the normally open, normally closed terminals. I will explain. So how many, in the question itself they are asking how many connecting terminals are there. So SPDT switch has a three connections. How many connections? Three. So option C is the correct option. We'll see what are the three connections. The first connection is no, that means normally open. Second connection is NC, normally closed. And third connection is C, common. So these three connections are there. So see here, normally open, normally closed, and common point. This is a common point. Three connections. So the input current enter the switch through common, and makes the circuit either with no, normally open, or NC, normally closed contact. Okay, this is about the second question explanation. I hope that everyone is clear. How many connecting wires there for the SPDT switch? Three connecting wires. For example, in the maybe coming examination 2022, how many terminals for SPST? You can answer, right? SPST, single pole single through switch. There, single pole single through switch. This is a symbol for single pole single through switch. How many connecting terminals are there? Two connecting terminals in this case. Okay, so this is about the question number 2 explanation. Okay, next one, question number 3. If the current flowing through the conductor and V is a potential difference across the ends, Ohm's law is expressed as. So they provided some voltage, current flowing through the conductor as well as voltage. They are expressing the Ohm's law. Normal expression V, all these parameters are given. V is equal to IR. This formula. But anywhere it is found that V is equal to IR? No. But from the laws of resistance, R is equal to rho L by A. You know that R is equal to rho L by A. What is mean by rho? You can also write it as a rho is equal to 1 by sigma, 1 by conductance, 1 by conductivity. Resistivity is equal to 1 by conductivity. I can replace it here, L divided by A. Now R is replaced by 1 by sigma L divided by A into I. We can see that which one is correct here. V is equal to 1 by option A. V is equal to 1 by sigma L by A into I. This is the option A is a correct option. All of you clear? So this is a question from 2017 question paper. Next, question number 4. A filament lamp of 40 watts 110 volt is connected in series with resistance R. If the supply voltage is 230, the value of resistance R should be. So let me draw the diagram here. So we have a filament lamp, right? This filament lamp connected in series with some resistance. We don't know that resistance value. Okay, that resistance, and it is also connected to the some voltage. That voltage will be so here connected 230 volt. So this particular lamp having 40 watt 110 volt. Okay, this is about the circuit. They are asking about the resistance value. Okay, it is easy. If you want to find out this resistance, some fundamental formulas. R is equal to V by I. Okay, clearly listen. R is equal to V by I. I value? You don't know. V value? You don't know. How to find out both the parameters? See, this is a 230. This is a 110. That means here 110, here 230. What about voltage drop you may expect here? 230 minus 110, right? Then only our lamp will be glowing or emitting the light safely, because you are connected 110 volt rating, but you are providing 230. Lamp may be damaged if you are giving 230 volts. That means some voltage drop is required. How much voltage drop is required? So 120 volt. Got my point? How many voltage now? How much voltage is required now? 120 volt across the resistance. It is a first step. So voltage parameter. Once again I will repeat. This is the 110 volt. This is the 230 volts. Just apply the KVL. 230 minus 110, that is a 120 volt drop is required across the resistance. Next, coming to the current. So current, nothing but a current flowing through total entire circuit is series. That means the current flowing through this wall, this particular lamp is same as current flowing through the resistance, right? That's why I'm going to find out the current. I is equal to, formula for power, P is equal to V into I. From that, I is equal to P by V. What is the power is given? 40 watt. What is the current? Voltage 110. That will be equivalent to 0.3636 amperes. Okay, you got current also, right? Once you got voltage, once you got current, therefore finally resistance is equal to V, that is a 120 divided by 0.3636, that may be equivalent to 330.03 ohms. So verify the answers. So where is a 330.330 around? So option D is the correct option. Is it okay for you? This is the way you need to find out the solution. This is the standard of examination. So your preparation, like you are taking one textbook, you are prepare, keep on preparing, but in the end of the examination, you may not be clear, because your theoretical concepts you should clear, and the practice is more important. Practice more and more problems, because in the syllabus numerically they mention intentionally in the syllabus at the end of every chapter, or circuit fundamental or resistive elements or whatever may be the chapter, they mention conventional problems, right? That's why you need to focus on the numerical examples also. In our mobile app it is doing that. So I provide some coupon code also, KVS 2023. If you are enrolled before 25th of December, you will get 2000 concession on that. Okay, if you are using this coupon code in our mobile app, you will get 2000 concession for those particular course, KVS TGT work experience teacher. Okay, here a linear element, question number 5, a linear element satisfy the property of, so the property of superposition as well as homogeneity. This is the option D. This is a question from 2017 question paper. Okay, in the examination this type of theory questions also there. That means the total entire examination is classified into numerical questions, theory questions, maybe it is a moderate, as well as theory questions, it is a simple questions. So this type of segregation is there. If you are attempt all these questions, then only you are in the merit list. Okay, next we are moving to the next question. So here question number 6 from 2016 question paper. So what they are asking, an energy source forces a constant current of 5 amperes 4 seconds to flow through a light bulb. So let me take, we have a constant current source. Okay, it is connected to the bulb or lamp. So what they are asking, what they are saying, so it forces to current of 5 amperes. That means the current of 5 amperes. What is the time? T is equal 4 seconds. Time flow through a lamp. So if the 3 kilohertz is given in terms of light energy, what is the light energy emitted here? 3 kilojoule. Okay, in terms of light energy, the voltage drop across the bulb will be, what they're asking, the voltage drop across the bulb they're asking. Okay, this is the question. First you need to understand the question, then we are find out in the solution. So here, if you are providing a current source of 5 amperes current source to this, you need to find out the voltage. Energy formula from our theory class, energy formula is equal to VIT, right? So what is the energy is given? 3 kilohertz, that 3 kilojoule, that means 3000, K means 3000. What is the voltage is given? You don't know voltage, you need to find out. What is the current? 5 amperes. What is the time? 4 seconds, right? So from that, V is equal to 3000 divided by 5 into 4, that may be equivalent to 150 volt. What is the answer now? 150 volt is the answer. Option A is the correct option. Okay, this is about the solution for this particular problem. Okay, we are moving to the 7th question from 2014 question paper. Okay, an electric iron was rated 110 volt, so 50 watts. If was put across the 220 volt, the new output power will be. Okay, this is the question. So from that, electric iron, I need to find out the electric iron resistance first. So P is equal to V square by R. You know this formula. From that, R is equal to P divided by R is equal to V square divided by P. What is the V? 110 whole square divided by power is a 500. We'll get 24.2 watts resistance ohms. Is it okay? So first you are finding out in the resistance. What they are asking, if it is across 220 volt, what is the new power? So new power will be, this is the, for example, P1 or P volt. So P new power is equal to again V square by R. But this particular time voltage is changes 110 volt square. But but iron is manufactured with the help of the some winding, maybe copper or iron, whatever may be winding. That winding resistance is always fixed, that is at 24.2 ohms. Whatever it may be the voltage you are applying, the resistance is a constant. That's why V square 220 by what is the resistance? 24.2. Then you will get 2000 watts. So 2000 watts is a power. So which is option? Option D is the correct option. Okay, this is also the second question from 2014, 16, 17 and 18 question papers. I hope that you enjoy the classes and then you know what is the standard of your examination. If you are interested, you can, in our particular video description, our mobile app link is there. You can download the mobile app and go to the preview, 2 minutes preview video. All the videos you can see the up to 2 minutes preview is there. If you are interested, you can enroll now. We are giving the offer for these 2 days, 2000 construction. If you are using the code of KVS 2023, you will get 2000 construction on the particular course. Thank you.